Imagine if you were completely paralyzed, unable to move, speak, and communicate with the world around you. How would you feel? You would feel isolated, helpless, like you have lost the ability to be the part of the life itself. But sadly, this is the reality for millions of patients today. But that's where my solution, ReVoice, comes in. Hello, I'm Vinayak Rajaram, a young student innovator. I'm here to present ReVoice, a brain-to-voice communication system that acts as a true bridge for those who can't speak. Decoding brain waves has always been a difficult challenge, but ReVoice makes it possible. It serves people with urgent needs, patients with tracheal or laryngeal cancer, those who are paralyzed, or anyone who has lost their natural voice. ReVoice fills the gap by being affordable, accessible, and providing an easy way for the patients to communicate in their own voice. Let me now explain what is an EDF file is, because it is the backbone of our project. One EDF file equals one recording for a patient. The file has two main parts, the header and the data record. The header contains important patient details as well as technical characteristics of the signals. It can also now store animation and events for better analysis. Right after the header, we have data record. This is where the actual EEG signals are stored. These signals must be contiguous, meaning they are stored directly after the header without any gaps. So the EDF format allows us to have both patient metadata and raw EEG signals together in a single file, making it much easier for us to process and train our models. Now let's look at the workflow pipeline of ReVoice. We start with hospital EEG data stored in EDF files. These are pre-recorded EEG signals from the patients. Step 1. We load the EDF signal into Python using MNE tools such as mne.io.read raw EDF. Step 2. We process the signals applying bandpass filters, notch filters, and noise removal to ensure clean brainwave data. Step 3. The filter signals are passed into our machine learning model where an auto decoder maps EEG patterns to voice signals. Finally, the output is generated as MP3 or audio speech, giving the patient a real voice again. Here you can see a sample code snippet. This demonstrates how the EDF file is read, how processing is done, and how the signals are prepared before being passed into the machine learning model. Now let's move to the code of ReVoice. The machine learning model. The model handles signal acquisition, noise removal, feature extraction, and mapping of brain signals to speech. As you can see in this demonstration, the final output is an audio MP3 file which plays the patient's intended voice. This is a major step of ReVoice. To processing, deep learning, and real-time speech output. Every stage has been designed for medical-grade reliability. This shows how ReVoice will evolve from a prototype into a fully functional device that can be deployed in hospitals and homes, making communication possible for the patients who have lost their voice. Now, the ReVoice prototype is in progress and it will be completely ready in 3 months. Our honorable collaborators: Forge Innovation and Ventures, PCB Designing and Fabrication Support; GKNM Hospital, access to EEG machines and patient data; KMCH Hospital, collaboration for EEG headset and testing; Engineer to Amphanol, software support guidance.